Assalamu alaikum, dear students. How are you? I think all of you are well in this pandemic situation. I am also fine. I am Hiron, Associate Professor and Head of the Department, Statistics Department, Mohila College, Dhaka. Welcome to all of you on behalf of Mohila College online class. Our today's topic is Bayes estimation. Second year honors major course statH 201, that is theory of estimation. To define Bayes estimation, we have discussed another definition. At first, loss function. What is loss function? We know in non-classical method of estimation, parameter theta is not fixed. Theta is not fixed. Since it is not fixed, so it is a random variable and it has a probability function. If we define z theta by another estimator t, then we lose something. This is called loss function. In non-classical method of estimation, parameter theta is not fixed. It is a random variable and it has a probability function. If we estimate this parameter by an estimator t, then we lose something. This is called loss function. Generally, it is denoted by L T theta. Risk function. Risk function. Expected value of loss function is called risk function. Expected value of loss function is called risk function. It is denoted by R theta. That is R theta equal to expectation of LT theta. If we define it, L T theta F T dt. Prior distribution. Prior distribution. Let x1, x2, xn be a random sample of size n from the density function fx theta. Let t be another estimator of theta, and theta is a parameter space omega. Then the probability function of theta is known as prior density function of theta. It is denoted by z theta. Let x1, x2, xn be a random sample of size n from a population having density function fx theta, where theta is unknown parameter. Let t be another estimator of theta, and theta is a parameter space omega. Then the probability function of theta is known as prior density function of theta. It is denoted by g theta. Next, posterior distribution. Posterior distribution. Let x1, x2, xn be a random sample of size n from the density function fx theta. Let g theta be the prior density function. Then the conditional distribution of theta given x, that is f theta given x, is known as posterior density function of theta and is defined by f theta given x equal to product of f xi theta g theta integration of f xi theta g theta d theta. Posterior distribution. Let x1, x2, xn be a random sample of size n drawn from a density function fx theta. Let g theta be the prior density function of theta. Then the conditional distribution of theta given x, that is f given x, is called posterior distribution of theta and is given by this. Bayesian estimator. Bayesian estimate. Again, common dialog. x1, x2, xn be a random sample of size n drawn from a density function fx theta. Then posterior distribution of theta is f theta given x1, x2, xn. If theta had be estimated such that it minimizes theta f given theta whole square f theta given x1, x2, xn d theta, then theta head is called Bayesian estimator of theta. Let x1, x2, xn be a random sample of size n from the density function fx theta. The posterior distribution of theta is f theta given x1, x2, xn, or f theta given x. If theta head be estimated such that it minimizes this function, then theta is called Bayesian estimator of theta. base risk, base risk, let L T theta we know be the loss function, R theta is risk function. Then expected value of risk function is called base risk. It is denoted by R T. R theta, G theta, D theta. Let L T theta be the loss function of theta and R theta be the risk function. Then base risk is expected value of risk function. It is denoted by RT and is defined by RT equal to expression of RT. This is posterior risk. Posterior risk. Expected value of loss function with respect to the posterior density function is known as posterior risk. Expected value of loss function with respect to the posterior density function is known as posterior risk. It is denoted by this and is defined by expectation of theta L T theta L T theta F theta given X D theta. Expected value of loss function with respect to the posterior density function is known as posterior risk. It is denoted by R P posterior, they are equal to that. Now Bayesian method of estimation. Bayesian method of estimation. We know our common dialog is that x1, x2, xn be an example excision done from a population having density function fx theta, where theta is random variable. Then the joint density function of random sample is denoted by fxi theta. Let z theta be the prior density function of theta. Then posterior density function of theta is given by d theta. This is posterior density function of Now, expectation of posterior distribution is called Bayesian method of estimation. It is the expectation of theta given x or expectation of theta given equal to theta b theta equal to is given x1 x2 and b theta or is theta given as this is Bayesian method of estimation. Advantage of Bayesian method of Bayesian method gives a consistent and band estimator. Bayesian method gives a consistent and band estimator. Band means best asymptotically normal. It also gives an estimator which is always a function of minimal sufficient statistics. It also gives an estimator which is always a function of minimal sufficient statistics. Bayes estimator is better than classical estimator. Bayesian method provides solution for problem which does not have solution from the classical point of view. Bayesian method provides solution for problem which don't have solution from the classical point of view. Bayesian method is a method of estimating the parameters of any statistical distribution. Bayesian method is a method of estimating the parameters of any statistical distribution. Our next definition, squared error loss function. Squared error loss function. This is an important topic. From order of x1, x2, xn be a random sample of size and roll from a density function fx. Theta, where theta is parameter. Let t be an estimator of theta. Then L t theta equal to t minus theta whole square is called square error loss function. Let x1, x2, xn be a random sample of size and roll from a population having density function fx. Theta, where theta is the parameter. Let t be another estimator of theta. Then L t theta equal to t minus theta whole square is called squared error loss function. This is the error difference between statistic and parameter is called error, and is squared, so it is called squared error loss function. Another definition, absolute error loss function. Absolute error loss function, if we define absolute value, then it is called absolute error loss function. So we shall define in this chapter loss function, risk function, prior distribution, posterior distribution, Bayesian estimation, Bayes risk, posterior risk, Bayesian method of estimation, advantage of Bayesian method of estimation, prior distribution, the squared error loss function, absolute error loss function. So viewers, no more today. See you another day, inshallah. Allah Hafiz.